Before I get started, I want to talk about Alex, because I know there's been some confusion about like seeing two different scores. And so I talked to them and they showed me a better spot to look. And it's, Jackie gave me permission to show this. Not laptop, PC. It is in module details. If you click on module details, you'll get like this kind of thing up. So like looking at Jackie's 9.2, 9.3, it says 85% on February 2nd. That's the gradebook score. 75% here. You're like, that's a discrepancy. All right. So the 85%, the gradebook score is not going to change. That's what you got on the homework. The 75% reflects that if they brought up topics later and say a post knowledge check or the topic came up in another question and you missed it, they went back and like noted that you might be like struggling in that area and they might slip in some more questions for that topic related for you later. So this means like your grade, it shows better in like the grade book score will show your grade book. What the pie wheel shows is like your actual level of displayed mastery.
Oh, like what you actually know about that.
Yeah, so you might have gotten the homework right, but not retained it.
Yeah, that makes sense.
Does that make sense?
Yeah.
So if it comes up again, if they bring the topic back and just do it again later, and you still mess them up. PreCalc, then it'll lower the score?
Okay, the number will lower your grade book score. So like she for 9.6 and 9.7, Jackie got 89%. It's a good score. It's the inverse fucking topic section. It's a challenge for a lot of students. When the stuff came back up later on, she didn't do that well. So it's showing that like even though she got the questions right at the time,
Right.
retaining it wasn't as optimal as it could be.
That was probably with the module check, because I was honestly rushing through that module check so I could do homework that was due.
Right. So hopefully the module checks are going to be a lot less now that I was able to adjust stuff. But that's what's going on with that.
Okay, perfect, thank you.
All right, so I hope you guys watched the little short video for 11.3 and 11.4. We just went over a bunch of stuff in 11.4 in the sport course. I'll have that video uploaded today. Today we're going to continue. And this is lecture day 15. And we're doing 11.5, which is on exponentials and logarithmic equations. And then 11.6 is on applications of exponents and logs. So a couple things to be aware of. I've seen some of this stuff before. One thing is if b to the x equals b to the y, this is true if and only if x equals y. Again, that's short for if and only if, the IFF. It means it goes both ways. If I start with b to the x equals b to the y, I can get x equals y. And I start with x equals y, I can swap to this. Going this way is called exponentiating. Exponentiation with base b. Going the other way, you can take the log of both sides. So I'll display this stuff down below. Exponentiating is literally taking both sides, treat as an exponent of base b. So I can literally just write a b underneath them and make the x and the y exponents. Let me say take the log of both sides. So if I took the log of both sides with base b here. Our exponent rules come into play. We can bring the exponent down. And each of these is 1. So I get x equals y. This really has another part, because that x equals y is going to come up again. X equals y if and only if log base b of x equals log base b of y. I think there's a better way to do this without memorizing the rules for it, which just has to do with a little bit of fucking reason. If these sides are equal, and this matches this, and this matches this, and when they are equal, the only way they are equal is if this matches this. Right? It just kind of fits. Same thing up here. B to the x equals b to the y. If the bases match, and we have an equal sign, the only way they're going to match is if the exponents match too. They should be the same value on both sides. A couple other things to note. You've seen it before. In fact, we showed it right here. Log base b of b to the x equals x. This is the same thing as natural log of e to the x equals x. And for the same reason. Bring the exponent down. And the log part equals 1. Because log 10 equals natural log of e, which equals log base b of b, which equals 1. I said that in the 335 one, but I think it's worth mentioning here when everybody's present. Ready to do some shit with this?
Yes.
So a quick guideline, like putting that together, like How to solve an exponential. Things where variable is in the exponent. A, isolate the exponential. And B, take the log of both sides. Solving logs. Isolate the log. May require combining. Combination. There we go, that looks better. Exponentiate. To solve. And last thing is must, this only applies to logs. Check your answer. Logs have a restriction on the domain. X has to be greater than 0. For log X. If that's adjusted in any way, shape, or form. The point is the inside of the logarithm has to be positive. Yeah,
So the logs are similar to square roots, the same. It's,
yeah, square roots have domain restrictions as well.
they're gonna be positive.
So things with domain restrictions. We have a midterm coming up next week, it can't hurt to mention this. So domain restrictions, log of X, X has to be greater than 0. Square root of X, X has to be greater than or equal to 0. And 1 over X, X cannot equal 0. So you don't want 0 on the denominator, you don't want negative numbers on the inside of a radical. And you don't want even 0 or negative numbers on the inside of a log. And put them here. Domain is all possible values for X. We've mentioned that before, but I'll just spit it out again here, and range is the same for Y. So our inputs and our outputs. look at some examples. Three to the two x minus one equals 5. This is an exponential problem, the variable is in the exponent. So we isolate the exponent. Isolate exponential, which is done. It's all by itself. Now we're gonna take the log of both sides using the base that's there. I'm gonna take log base 3 of both sides. So I have log base 3 of 3 to the 2x minus 1 equals log base 3 of 5. Davis is not anything ahead because he recognized what's going on here. How do I go forward from here?
So log three, the item 3 reduces just to 1.
That's gonna be 1, but I can't do that until
2x minus 1 goes to the front.
I gotta pull that out. 2x minus 1 times log base 3 of 3 equals log base 3 of 5. And as Davis said, that's 1. So I have 2x minus 1 equals log base 3 of 5. Here, the algebra is straightforward. Don't put the shit in your calculator yet. Calculator is always the final answer. Final option. We add 1 to both sides. And then I'll divide by 2. Or 1/2 plus log 3 of 5 over 2. Either one of those works. These are called, this is called the exact answer. On the problem on the test that had, there's a question like this on the test. You're expected to give me the exact answer and then an approximate. And that's where, when you see approximate, that's where you do the calculator work. And how can I do log base 3 of 5? Unless your calculator has a button for that, which I don't think it's going to. We can do the change of base. We do log of 5 with any base over log of 3. And here just use log or ln key. I recommend doing that first. So log 5 divided by log 3. A little sub-step here. 649,735. I'll add the 1 and divide by 2. Plus 1 is 2.46 divided by 2. X is approximately 1.23248676. And however many decimal places you're told to round to, do that. We use the wavy sign for approximate. And we use the equal sign for exact. I had this calculator a long time since I was a student here. Oh God, how many fucking years ago was that? 2009. It's been a while. I went to make a joke in another class related to World of Warcraft. And I realized the reference I was making happened in 2006. And I realized I had students in the classroom that weren't even fucking alive at that time. And I was like, ouch, ouch, that fucking hurts. It's that fucking knife wound right in my chest. All right, let me give you guys one to check out. Why don't you guys try real quick? 4 minus e to the x minus 1 equals 3. You guys must have an answer. You have an answer, David?
I think it's x equals 1.
Anyone else get that?
Yep.
I'll give you a little bit longer. I'm just saying. And if you get this, that's correct. 30 seconds or so. All right, so I'm guessing most, how did you do it, Davis? Did you move the 4 or did you move the e to the x minus 1?
I moved it 4 first.
That's how I'm guessing most people did it. Then divide by -1 or multiply by -1.
Both sides.
So take ln of both sides, or the same thing as log base e. That brings the exponent down. That's 1. What's this? 0. So x minus 1 equals 0, x equals 1. There is another way to do this one. And only when you're at e to the x minus 1 equals 1. This only works because the right side is 1. This is base b of any base to the 0 power. So instead, I could write this as e to the 0. And then do that, the bases match, the exponents match. But doing the natural log thing works. That's what I said to do. That always works. This only worked because the right side was 1. All right. You have a class with a 12-year-old in it, Michelle? Holy shit.
Yeah, I had a couple classes with like middle schoolers already, and it's eye-opening, man.
That's COS.
Yeah, and they even have a
Holy
high school on
shit.
campus.
Are you sure they were middle schoolers? Like, I didn't even know they allowed that. Like dual enrollment, they will allow high school students.
Well, maybe they jumped up to high school.
The school has to allow it though. The
Yeah,
high
but
school
I'm
has to
pretty
allow it.
sure he said he was 12. He was either 13 or 12, but he was not even in high school yet.
Maybe it was a young freshman. Like a 9th grader could be
Probably.
13. The average is 14, but a fast student could be a 13-year-old.
Probably, but he was 12. He was dead serious.
He's talking a kid either way.
Yeah.
God damn, you're like, this kid's gonna be smart.
I'm out here shivering with my associate's degree at 20, yet he's already 12, about to graduate with his bachelor's when he graduates.
Don't compare yourself to other people, that's never beneficial.
Damn.
Don't compare yourself to people that are working faster than you and learning faster than you, that's just demoralizing. And never compare yourself to people that are working slower and thinking that you're superior, because that just makes you an asshole. Just don't do it. Don't compare yourself to others. Everyone learns at their own pace. So. What can I do? Well, what's the first problem that you have with this, Jackie?
It's math.
Besides the math,
Fractions.
it's a fraction. What do we do with fractions?
Don't like them. But fractions.
Fuck fractions. We get rid of fractions by multiplying them out. So the left side just becomes 10,000. Now we want to isolate the exponent, which means dividing by the 5,000. Now what?
We still have a fraction.
We still have a fraction. But that's on the inside. This is just a number. We can, when we throw this in a calculator, this is going to give us a number.
Do we do the log or something?
We can do the log, and I'm not going to choose the log of this because that's going to be a fucking horrible number. I'm just going to take fucking any log. Let's do log base 10.
Can you do that?
Yes, we can. I wouldn't tell you we could do it if we couldn't do it. The point is that we can bring the exponent down now. I think this actually cleans up without being an ugly, too bad of an ugly decimal. So that's 0.15. Yeah. So this is 1.015 in here. All right, so right now, T is multiplied by 4. And it's multiplied by this log 10 and 1.015. We're going to divide by it. That is an exact answer. We can do natural log. We could do log base 2. If we did log base 2, this top part turns into a 1, but the bottom part's harder to throw into a calculator. If I throw this into a calculator, since I use the log that's available on the calculator, I can just do that. Log 2 divided by log 1.015 divided by 4 is approximately 11.6388141. We generally don't start here. But this is actually a generic starting spot for compound interest, well, not generic. I started with $5,000. And I want $10,000. And it's at 6% interest. Compounded quarterly. That's the equation for this. That setup. Which is something we're gonna do in 11.6, so like, there's a reason why I'm showing you these every once. Let's take a quick gander of what we could do here. Any ideas?
Is that a minus 4EX?
Yeah. Minus 4EX in there.
The E's or no?
I can't because they have different exponents.
Saying that because there's two of them? Oh, no,
If they were multiplied or divided, we could combine them, but as they are, we can't. Any ideas?
You want +5 first?
Actually, no, not here.
You take the natural log of the whole thing.
We could, but that's gonna cause a problem.
Just move one of the E's over. To the 0 side,
We could try that, but that's also not gonna work.
and we just throw it away. Yes.
If I say U equals e to the x, what does this equation look like?
Oh,
Yeah, that thing,
quadratic one, no.
it becomes a quadratic function.
Yeah.
U squared equals e to the 2x. I'll do a quick bit of factoring. But it ain't about you, we didn't start with you, it doesn't have to be you. I'm gonna put it back in. And now we can hit it with our natural log. Oops. That make sense? There's a problem.
There's a negative in there.
There's a negative in a log. It doesn't say log, but it's a log. That's log base e and -1. And we said that's a domain problem. So kiss that motherfucker goodbye. God, that'd be demoralizing. I'm a 13-year-old in my class.
So then our answer would be just the X. And
X equals natural log of 5, yeah.
that's the exact answer.
Yep. All right, that's kind of the exponentials. Let's take a look at some logs. So for both of these, it was isolate. And then solve. Here we'll solve by exponentiating. So I'll subtract 1 from both sides. I'll divide both sides by -2. And this is a base E. So I'm going to treat both sides as exponents for E. And E, the ln of E of X, or ln of X is just X on the left side. On the right side, we have E to the 5/2. Log problems out, we have to check our work. So I'm going to take that and I'm going to stick that in. Does that equal -4? Rules of exponents is I can bring the exponent down. That's just 1. And 2 times 5/2 is 5. 1 minus 5 does equal -4. So that's a valid solution. So those properties of logs come really fucking handy. If you want to see more done with them, last hour. From 2 to 3, we did like nothing but properties of logs for an hour. We walked over to the proofs, I did more problems. I'll upload that video tonight. Any questions?
So putting both sides of the equal sign of the equation. Under like applying the log to each side and turning both sides into the exponent, it's effectively the same thing.
They're similar.
It's similar but not the same.
They're not the same all because doing the log of both sides is designed to get the variable out of the exponent. Exponentiating both sides is designed to get rid of logs. When the variable's trapped inside a log, you gotta exponentiate to get it out. When the variable's trapped in an exponent, you gotta take the log to get it out. Because logs and exponents are inverses. So they cancel each other out. That's the great gift. Jackie just looked like traumatized.
Every time I think
Wow,
it's the worst, you give me migraines, not you,
every day I see you, this is the worst day of my life.
yes,
That's fucking great.
yes.
That makes, that's a feel-good moment right there.
It's not you, it's these numbers.
That's actually from the movie Office Space.
I love office. I wanna run this building.
Office Space is fucking great. If you guys haven't seen it, it's an old movie. It's great. It's really better if you've ever worked in an office though. If you've never worked in an office, it'll still be funny, but
That printer, when I worked in the pharmacy, I have wanted to take the printer up to the parking lot many times.
alright, let me give you guys one. Log base 4 of x squared minus 3x equals 1. Go. I isolated the log for you because I care. It's all by itself. So Jackie, when you're perforating people with your wicked ways, how did you learn where to stab them? That's fucking scary. What do you mean it's based off of feeling?
Cause your body is connected in one, like, you're all connected everywhere. And you're able to find these pressure points, touching the body and being able to feel where it is. It's more anatomy,
Yeah, it's just, so you had to study a lot of anatomy,
I haven't yet, but
where you're going to.
Yeah.
So you're gonna have to like spend some time and it's probably not gonna be easy learning where to stab people.
well, I don't know.
It's just, it takes, you're gonna have to memorize where to stab people, right? Effectively. What pressure point does what? Like maybe one in the fucking head. Like helps your wrist or some shit like, it's not always localized.
No, it's not.
So you have to, you're gonna have to remember what pressure points fix what ailments.
Not necessarily.
You just stab everywhere.
Okay, no, cause I've been reading my book already on it, and it's like, it's more of your. Knowing what organs and. Like what elements kind of go with it. In order to like meaning it. I have a chart.
There's a chart, there's a lot of things to memorize though, right? That's all this is, there's a lot of things to memorize.
And it's so hard, it's like, it's so difficult. I don't know.
Now, what are you gonna do? I tried. I can't make you like it, but hopefully I can make you be able to do it.
You can, but then when I get home, I have no idea what I just did. When I do that, I have no idea what's going on. I'm like, great. This is useless.
Alright, what do I do on this one? So we get rid of logs by doing exponents. We're gonna use the same base. Use the base of 4, treat this as an exponent for base 4. Treat this as an exponent for base 4. And the 4 log 4 cancels. And 4 to the first power is just 4. Unless you want to complete the square, I would move 4 over. And you could use quadratic formula, but factoring works and it's probably quicker.
It can't be -1.
We're gonna check.
Oh,
We gotta check in what we started with. So our checks are gonna be. Log base 4 of 4 squared minus 3 times 4. And our x to the -1 is gonna be log base 4 of -1 squared minus 3 times -1. This is 16 minus 12, which is log base 4 of 4. And this is -1 squared is 1, and -3 times -1 is plus. So both of them lead to that. And that does equal the right side, it equals 1. Doing the full check like this verifies it. Generally, if you know you did everything right up to here, you're just really looking to see, is the inside positive or negative? If it's positive, even if it's all fucked up, because you might have like a 7.6 over here, and you're never gonna fucking identify that by sight.
It's like the whatever is in the parentheses at the end, as long as it's positive.
Yes,
So-
whatever at the end is positive. And this is positive.
So x can be negative in an equation. It's-
As long as in the original equation, it doesn't violate any laws. Let's take a 6 or so minute break, 6 minutes or so. We're gonna do a little bit more in this section. Before we do 11.6, 11.6 will be faster.
Here's use the log of 1.
All right, let's do log base 2 of x minus 1 plus log base 2 of x plus 3 equals 3. No, you cannot just raise both sides to the power of 2 yet. I know, I see Davis going, I'll do it. The problem is this plus sign really screws that shit up. I mean, I guess you could,
Yeah.
It's still gonna work.
The log, yeah, you can distribute it, right?
but you're better off combining first. Cause as an exponent, it's really gonna bake your noodle. We take the base, we use that as our exponent. Two cubed is 8. This is one I clearly should start on another page, because it's gonna be a 2-pager.
And is that the two cancels the log too, right?
Yeah. That cancels.
When we're combining two log sections, that leads to the factors being multiplied, not added.
Yeah. So addition turns to multiplication. Subtraction turns to division.
Like the exponents.
Yeah.
Yeah, it's the same.
But it's very much because of the exponents.
Yeah.
In fact, I derived all of them. If you watch the video for 335 later on, the first 10 minutes are deriving the log properties. And it's basically switching shit to exponents and going from there. Here though, this is gonna give us an x squared if we distribute. If I distribute, I got a minus x and a plus 3x is plus 2x. Minus 3 equals 8.
You want that to equal 0?
We do want it equals, there, see, you have learned something. So we'll subtract the 8 over. Damn, this is a shitty problem.
Yeah, so second one, that's exactly. You use the quadratic formula?
Yeah, we're gonna have to use the quadratic formula.
Is it because we can't factor out?
Yeah, 11's, the only factors for 11 are 11 and 1, and no combination of that equals 2.
So if you can't factor it out like normally like that, you wanna do the quadratic.
That's correct. So we're doing the b squared minus 4ac square root, and we got the negative b over 2a. So -2 plus or minus square root of 2 squared minus 4 times 1 times -11. Over 2a, which is 2. That is 4 plus 44 is the square root of 48. Oh, this is gonna simplify a little bit. I could factor out a 4. I can factor out more than a 4.
2.
I could take out a 16. 48 is 16 times 3. So that's gonna turn into plus or minus 4 root 3 over 2. Which is -1 plus or minus 2 root 3. So we have x equals -1 plus 2 root 3. We got x equals -1 minus 2 root 3. And where we gotta check them is in log 2 of x minus 1 plus log 2 of x plus 3. Well, into both. Now, if any of them is gonna give me a problem, the x minus 1 is gonna give me a problem before the x plus 3. Because we're subtracting 1, so it's making the value lower. So I'll just check this one. -1 or plus 2 root 3 minus 1, is that greater than 0?
Yes, yeah.
Yeah, 2 root 3 is 3.46 minus 2. This is about 1.46. That's a good to go. So this one works. If I check the other one, I've got -1 minus 2 root 3. Minus 1, is that greater than 0? All of these are negative. So this is negative, so that's a fat no. So that's a cancel that motherfucker out. And if it worked in this one, it's gonna work in this one because that number's 4 larger. Now, I didn't go through it and verify that the equation actually gives me a 3. Plugging it all in, I just checked to see if it's positive. If you actually plug it in and solve it all, it should work. That's a lot of tedious calculator work that I don't think is worth your time. A quick thing, if they ask you to find inverses. I'm not gonna do it on the exam, but like the homework might have it. And I'm not gonna do the whole thing. But I'm gonna remind you how it works. So I'll set up one that's got a log and one that's got an exponent. Remember, the first step is rewrite them as y instead of the function sign. Then swap x and y. And solve for y. I guess I have time to do them. This isn't too bad. I'll take log base 2 of both sides. If I subtract 1. And that equals f inverse. Here I will exponentiate with the same base. And that's going to be g inverse. So inverses are swapping x and y, solving for y again. You like this?
Yeah. We're not that.
Question, doesn't that one need an x, need the exponent?
That's fine. We're just finding the inverse. Just finding the inverse. An exponent should turn into a log, and a log should turn into an exponent when you do the inverses. All right, I'm gonna hit stop video and we're gonna start a new video.